Okay, we are looking at derivatives as a rate of change, and the last topic that we need to talk about is motion along a line. So in this section, we are looking at velocity again, velocity, speed, and acceleration. So where velocity, let me get this here, velocity of the object is given by s prime of t, and the speed is actually the absolute value. Speed is the absolute value of velocity. And the acceleration of the object is, of course, v prime or s double prime. As we say, the first derivative of velocity is acceleration, and the second derivative of position is velocity. I kind of marked this graph up a little bit, so I hope it doesn't distract you too much with this, but we're picking up with this graph where it says a ball is dropped from the height of 64 feet. Its height above the ground in feet t seconds later is given by s of t. So that's your position function. And the ball hits the ground at 2 seconds. Now, if you're looking at this graph and you're saying, okay, it's clearly 2 seconds, and then you can plug it in and you can say, oh yeah, that's right, it's a height of 0. But remember, there are times where you're going to have to say, okay, you're going to have to set this equation equal to 0. E equals to 0, and you can clearly see that you would probably factor it or do something and find t is equal to 2. All right, and I think I have that down here. So the ball hits, the first thing I'm going to do when it says, what is the instantaneous velocity of the ball when it hits the ground? It's not 0, okay? So you have to understand that, because when it hits the ground, it still has that velocity with it instantaneously. So if you take and you solve negative 16t squared plus 64, if that's what you have to do, and you get t squared is equal to 4, then you can clearly see that t is equal to plus or minus 2. So that would be the first thing I would do. Here it's kind of clear. Then the second thing I would do is, well, what is the velocity function going to be then? So you can see that it's negative 32t, right? So negative 32t. And then I'm just going to plug in. Now, someone might say, what is the instantaneous rate of change? It doesn't matter if it's positive or negative. You just want to know how fast it is. So then s prime of 2, s prime of 2 seconds, the position at 2 seconds rate of change, or instantaneous rate of change, is negative 32 times 2, which is going to be negative 64 feet per second. Negative 64 feet per second for this, okay? So what is the average velocity now? What is the average velocity for the first 2 seconds? So then you have your information already at hand. So you have s of 2 minus s of 0. So that's just average velocity. So is equal to s of 2 minus, and that's the average rate of change in position, is average velocity over 2 minus 0. So s of 2 is equal to 0. Minus s of 0 is 64 over 2. So we get then negative 32 feet per second. Now, but it does say what is the average velocity during its fall. So because it's talking about the fall, you really could say this, or you could say 32 feet per second, the average velocity, because we're talking about how fast it's falling. So we take into consideration the direction already, so we can say it's positive 32 feet per second. Okay. Then a particle moves along a coordinate axis in the positive direction to the right. Its position at time t is given by the function that you see. T cubed minus 4t plus 2. I want to find the velocity at 1 second, it's this, and the acceleration at 1 second, and use these values to answer the following questions. Is the particle moving left or right from right to left at time t is equal to 1. So remember, if the velocity is, here I have a little something already, greater than 0, it's you're moving right. If velocity is less than 0, you're moving left on the number line. So we first get the velocity, we get 3t squared minus 4, and then acceleration we'll do is 6t. So we have all of our information, and we want to know at time t equal 1. So we're just going to say v of 1 is equal to 3 times 1 squared minus 4, and a of 1. Wait a minute. What's a of 1? A of 1 is 6 times 1. Okay, so I'm going to save a little bit of space here. Okay, so now a of 1 turns out to be 3 minus 4, which is negative 1. Negative 1. And acceleration is 6. So now, something about velocity. If velocity is negative, the particle is moving left. And if acceleration is positive, then that gives some more information here, but that's all we need here, right? Is the particle left or right at time t equals 1? The particle is moving left because velocity is less than 0. Is the particle speeding up or slowing down at time t is equal to 1? Because the velocity at 1 is, here I'm going to move this over because it doesn't really go there. If velocity is 1, velocity at 1 is less than 0. And acceleration at 1 is greater than 0. That means, like, picture this way. Okay, so you're moving left, but the acceleration is greater than 0. So what I'm going to do is I'm going to show you what velocity would look like. So velocity, you're moving that way, right? You're moving left. But acceleration is moving right, going to the right. It's moving in the positive direction. So picture it like this. Your velocity is negative because you're moving left, but your acceleration is positive. So you can see it's like putting the brakes on. So your acceleration is a force that's working against the velocity, okay? So right now you could say the particle is slowing down. And this is because acceleration and velocity have opposite signs. And that would be something good to add to this. Acceleration and velocity have opposite signs, then your particle is slowing down. So if the velocity was positive and the acceleration was negative, then the particle would also be slowing down. But, and let me draw another, this is a slowing down, but let me add one more thing here. I think that if they both go the same direction, like this, here's velocity and acceleration, then it's speeding up. And it could go this way, velocity and acceleration. So again, speeding up, both these situations, okay? The position of a particle moving along a coordinate axis is given by this function. So I want to find v of t. So all I did was took the derivative, that's s prime of t. And there you go, there you have it. Boom. And then at what time is the particle at rest? So you set it equal to 0 and you solve. So I'm going to factor 3 out, and it's going to be t squared minus 6t plus 8 equals 0. and I believe you can factor that still, t minus 4, t minus 2. So you get at t equals 4 and t is equal to 2, right? 4 and 2. So the particle is at rest, is at rest at 2 seconds and 4 seconds. On what time intervals is the particle moving left to right? So left to right would go this, left to right. And then right to left would go this way. Consider that. So what we're going to do is we're going to take our information and we're going to say, okay, it moves left and right according to, there's our function. And here we're going to take this. We've got a lot more of this to do in the future. But we're going to take the factored form and I'm going to put these two numbers on a number line to test. I've got 2 and I've got 4. So I'm going to pick a test point on the interval here. I'm going to pick 1, I'm going to pick 3, I'm going to pick 5 as a test point. And I'm going to test this product that I have, the product 3 times t minus 4 times t minus 2. And addressing this issue, I'm going to say whether or not the interval is going to be positive or negative for the velocity. So I'm going to use 3, I can leave the 3 out. I have 2 parentheses that I'm going to replace with a sign. I have t minus 4 and t minus 2. 3 is positive. You can put the 3 in there if you want. It's not going to change the sign of your velocity. So then I'm going to put in 1. 1 minus 4 is negative. 1 minus 2 is negative. Therefore, now this is your velocity sign. This is positive. So that means velocity is greater than 0. So what are we doing? Moving left to right. We're going in the positive direction. So left to right. And then 3, if I put a 3 in as a test value between 2 and 4, I have 3 minus 4, negative 3 minus 2, positive. So we know our velocity is negative on this middle interval. And so we know that velocity less than 0, you're going to be going right to left. And then if I put a 5 in, 5 minus 4 is positive, 5 minus 2 is also positive. So this is a positive velocity. Velocity is greater than 0. And see, I'm using this expression up here, the factored form. So then I know I am moving from left to right here. So on what time intervals is the particle moving from left to right? From. And I think I'm going to put from 0, you begin at 0. So even though I have a 1 there, I probably close the shop up here. It's going to, this is at 0. So it's moving left to right on 0 to 2. And at 2, what happens at 2? It stops. So it's 0 to 2. We're not going to include it. And then union with 2 to infinity. Okay. I mean, it doesn't have a story here that's going to stop some, so it's just a perpetual motion. I use the information obtained to sketch the axis, to sketch the path of the particle along the coordinate axis. So in the diagram, we start off at t equals 0. At t equals 0, we'll make a little chart. Then s of 0 is equal to 4. So at t equals 0, I'm going to use a different color here. You're right here. That's where you start at t equals 0. And sometimes in a diagram like this, when you're drawing them, you label them with a time value, okay, because you're moving along one axis. Okay, then at 2, what's s of 2? S of 2 turns out to be, s of 2 turned out to be 24. 24. So then from that point, you're going to go to 24. And this is t at t equal 2. Now remember in your diagram up here, there's a direction change here. And there is also a direction change, dir, direction, sorry, CHG. So I'm going to go from here to here. And sometimes it'll put a little arrow showing the movement here, right? And then now we're going to go to t is equal to 4 because that's the next one. So we have s of 4. And that's going to be, what s of 4, I got 20. 20. Okay, so let me mark this just to be sure. T equals 2 is right here. And we have, you see I'm on the number line, 24. And then I'm at 20. So somehow I got to turn around here and illustrate that. So at t equal 4, it goes like that. And then I don't need that t equal 4 there though, because there's another turnaround there. So then it's going to turn around again, and it's going to head back to the right, left to right, okay? So going down like that, going back like that. Okay, something like that. So t is equal to 4, you're at 20, but then it turns back around and it goes off to infinity then. Velocity stays. Velocity is greater than 0, so it's going out to the right. Okay, it's only on this little section here. Put some highlight green here. This little section, the velocity is negative, and it's that right here. Okay, all right, that's all. There's a little bit more left to do, and it's not too bad. I think we could probably finish it up. Let's do that. So in this section, we're talking about cost and revenue. So in addition to analyzing motion along a line and population growth, derivatives are useful in analyzing changes in cost, revenue, and profit. The concept of marginal function is common in the fields of business and economics and implies the use of derivatives. So what it's about when we say marginal, the first one, marginal cost, we're talking about the cost to purchase the next item, or the cost of the next item we make, the very next. And the same thing is true with revenue. Revenue, marginal revenue, is the revenue of an item. Like, how much am I going to bring in for an item for the very next one? Like maybe the 101st item. So after you've sold 100, what's the 101st revenue? So that's what marginal means. If P of X is equal to R of X minus C of X, that is the marginal profit, if you will. You see that. And it's pretty much, you're just going to be taking the derivatives here. Okay, so marginal profit of X is P prime of X. Okay, looks kind of tough, but it's really just the derivative again. Okay, so on this one, we have this. It says, assume that the number of barbecued dinner can be sold X can be related to the price charged P by the equation P of X is equal to. So here's the price. And remember, if that's the price and you're going to bring in revenue, you have to multiply that price by X, the number of things that you're selling, right? So we want to, in this case, the revenue dollars obtained by selling X barbecue dinners is given by R of X is equal to X times P of X, which is equal to X times 9 minus 0.03X equals, and now we have a quadratic. Okay, and you can see that I have that right here. But that's only defined from 0 to 300, okay? Use the marginal revenue function to estimate the revenue obtained from selling the 101st barbecue dinner. Compare this to the actual revenue obtained from the sale of this dinner. So we're going to take R prime of X, and that's going to give us negative 0.06x plus 9. So there's our derivative. And then we want the change. We want R. We want to look at R of 101 minus R of 100. What is the difference in revenue there? Because that would give you, it would give you 600, hold on just a minute, 602.97 minus 600 for R of 100. We have this equation for R up top. Okay, and when we do that, we get $2.97. So that the marginal revenue is a pretty good estimate. So if you would take the marginal revenue, so if I do take the derivative and say, well, what would it be? What is R prime of 101? And it's equal to negative 0.06 times 101 plus 9. Calculator. I'm just going to plug that in. I don't have an answer for that. And I think we're wrapping things up here very quickly. And I'll put this last video link in. So I have negative 0.06 times 101. And then plus 9, and what do I get? 294. So according to the derivative, it gives me this is R prime of 101 is equal to $2.94. So the marginal revenue, according to the derivative, is coming up with 294, whereas the difference between the revenue is 297 if I calculate it using the function. So they're very close. I think it's, when I read that, it's like, well, for the 101st barbecue dinner, and it says use the marginal revenue to estimate the revenue obtained from the 101st barbecue dinner. It's going to be $2.94. Okay, so that'll be the money that comes in. So the money that comes in minus the cost is equal to the profit. But in this case, we're just talking about money coming in. Okay, that is it. And I will talk to you soon. And have a good day. And probably about 5:30 on Monday and Wednesday. And we'll meet again. Have a good one. Bye.